this video, we're going to approximate the area of a region bounded by a set of curves. We're going to let delta x equal 2. We're going to divide the region into 3 subintervals, and we're going to use left-sided endpoints. Now, basically, this is a really early breakdown introduction to what a Riemann sum would be. All right, a left-sided Riemann sum. But early on in a Calc 1 question or a Calc 1 class, they might not introduce that term right away. They're just going to get you used to the idea of you're calculating the area under this curve. You are approximating it. All right, they're going to introduce left and right-sided endpoints. They're going to subintervals that you're going to have. Okay, so with that being said, then here, let's go ahead and get started. We've got an upside-down parabola with a vertex at 10. That curve has already been drawn. All right, your y equals 0 is the x-axis here. The x equals 0 is the y-axis here for a boundary, and then the last boundary, x equals 6. All right, which I'm not going to show that boundary on there because we know we're focusing on this area under the curve. I've got a delta x of 2 and 3 equal subintervals, left-sided endpoints. So I'm going to start drawing my rectangles here. I'm going to start in the far left-hand side. I'm going to come all the way up to the curve, touch the curve. I want a rectangle that has a width of 2, delta x of 2, and then come down. Then there is my first rectangle right there. All right, now we're going to now have a second rectangle. I'm going to go up the left-hand side until I hit the curve. I'm going to go a delta x2 over and then back down. So then I have a rectangle, my second rectangle right there. My second sub-interval region is right there. I'm going to come now for my third one. I'm going to go up the left-hand side. I'm going to hit my curve. I'm going to have a delta x of 2 for the width, and then I'm going to come down. So that basically is what the picture looks like. All right, so obviously we can tell if I take the area of each of these 3 rectangles, I'm going to have an over estimate. So sometimes they will ask you to identify over or under estimates as well. But let's just go ahead and calculate the area now based on the area of these 3 rectangles. So for the first rectangle, I have a width of 2 and a height of 10. And then for the next rectangle, again, I have a width of 2 and a height of 9. And then for the last rectangle, again, a width of 2 and, whoops, that's supposed to be a time sign, and a height of 6. All right, so real quick, basic math here, we'll have a 20 and an 18 and a 12, and then add that up, we're going to get 50. All right, units squared, if you would want a label on that. All right, in Calc, once you start doing those Riemann sums, then we generally don't label it with any type of units squared. So that would be dependent upon your professor. Now, since each one of these had a delta x of 2, it was consistent. Technically, I could have just done 2 times the quantity of 10 plus 9 plus 6. All right, another way to write it, but I prefer to show it this way for that very, very beginning Calculus 1 student so they get the idea that they are just adding up the areas of that rectangles. All right, and then you can classify the type of rectangles that were used here. What type of rectangles were used in the approximation in part A? Okay, that would be, they are called circumscribed rectangles. All right, and they are that way because they are going to give us that overestimate. Okay, it is outside the curve just a little bit more, so they are referred to as circumscribed rectangles. So again, just a basic, really early on introduction to these left-sided endpoints, dividing a region into equal subintervals, and then approximating the area. Again, in a Calc 1 class, this will ultimately lead to what's called a Riemann sum. Definitely, thanks for watching. If the videos are helping, please share with your friends so they can benefit too. And don't forget to subscribe to the channel. Thanks.